Hello viewers, and welcome to this online lesson where we shall look at common penalties that students are penalized when they make mistakes in chemistry examination at KCSE level. I am your teacher, Steve Gitau, and please join me in the YouTube channel, Steve Gitau 3660, and I'll be very grateful. I'll read that again. My YouTube channel is at Steve Gitau 3660. Kindly subscribe to my channel so that anytime I upload a new video, you'll be the first one to be notified. Straight away, let's look at today's lesson. The common mistakes students make during KCSE exam. Number one, we have writing of the chemical equations. You find that when the chemical equation is well balanced, half of the marks are already scored. So the chemical formulae must be correctly written. So the students here are encouraged to master on valences of the elements and valences of the radicals. How well do we write calcium nitrate? That's the kind of thing that we're talking about here. Half of the marks are on correct chemical formulae. The other half comes through balancing and correct state symbols. However, it is important to note here that for elements whose chemical symbol has two letters, the first letter is always a capital and the second letter is a small letter. Take for example sodium. N is capital, A is small. Now, this must be obeyed also when we come to writing the chemical equation. The chemical symbols must have the same font. For example, in my first example given there, zinc reacting with HCl to form zinc chloride and hydrogen gas, you realize I have put all at equal or same font size, and it's balanced, and the state symbols, whether it's solid, aqueous, that means in solution, or gas, are shown. In the second example, which is wrong, we are seeing the product, zinc chloride. The zinc is shown in small font, smaller than chlorine, and that is wrong. Secondly, we need also to look at the way some of the common symbols are shown together with the balancing numbers. It must be noted here that the numbers that are used to balance should not be in contact with the chemical symbols. Take for example, you wanted to balance zinc chloride with a 2 and then zinc Cl2 and aqueous. Each of these must be disjointed, and we do not join up the symbols. We don't join up the chemical symbol with the state symbols. 2, and very important, is the letter L. The letter L in chlorine should be small letter, a stroke. The same case with the letter L in aluminium. Students make a mistake of putting or writing aluminium as capital A and capital L, whereas it should be a capital A and a small letter L, and that is the correct way of showing that. The other item that I would like us to note here is that equations which are well balanced but have wrong or missing state symbols are penalized half the marks, unless the equation is that for an organic chemistry part. It's drawn from organic chemistry. For example, we have the reaction between methane and chlorine in the substitution reaction, whereby chloromethane and HCl are formed. You find that it will not be penalized when you do not show the state symbols for equations in organic chemistry. But for equations in inorganic chemistry, that the state symbols must be shown, and if they are not shown, you will lose half of the marks. Chemical equations that are not simplified will not score. Take for example the reaction that I've shown there between hydrogen and oxygen. We balance that by having 2 molecules of water or 2 moles of water. And in the second equation, we have a common factor there too. That shows that that equation is not simplified and it is wrong. So always, learners, let us simplify our equations as we give the final Number 2, we have several correct points. And then possibly a student puts one wrong answer. A wrong answer will cancel a correct answer scored earlier in the same question. For example, if the student is required to give 2 correct points, but a candidate writes 3 correct points and a 4th wrong point. So get me right. This question requires 2 correct points and a candidate writes 3 correct ones but adds a 4th correct point. The candidate will score 1 point and the 4th point, which is wrong, will cancel the second correct point. Therefore, it is advisable for the candidate to give the exact number of points required. So that is very, very crucial. That sometimes we find students putting up more than the required number of points, and in course of doing that, one of the points is wrong. That wrong answer will be very detrimental because it will score -1. A wrong answer will cancel a correct answer which was scored earlier in the same question. So let's be very, very careful. Maybe I can give an example. In the Haber process, the student is required to mention 2 raw materials that are required there. Chiefly, we have hydrogen gas and nitrogen gas. But a student adds at that point C and says chlorine gas is required. You find that this third point, chlorine, which is wrong, will have deduction of -1 from the 2. So instead of the student scoring the first 2 correct and earning 2 marks, the student scores 1 point because one of the correct answers was cancelled by a wrong answer provided by the student. Number 3 is all about calculations. How do we do calculations? We find that calculations are marked consequentially. A wrong answer or a wrong step earlier in the question is penalized once, and the rest of the working marked according to that wrong calculation. For example, maybe the student was calculating on the number of moles, and he was supposed to get, or she was supposed to get 0.25. But the student wrote 0.025. So that is penalized at that level. But when the student keeps on using this value 0.025 in the next working below that, then the student is awarded the marks. So what we are saying is that a wrong step earlier in the question is penalized once, and the rest of the working marked according to that wrong calculation. The other item we need to note is about units. If a candidate omits units which were in the stem, that is, the units are indicated in the question, then there is no penalty. For example, maybe the student did not show grams, but they were indicated in the question, and only gave the correct answer 2 grams, then that candidate earns the marks. The other item is about the way we write the units, the correct way of writing or showing the units. Kilojoules. We need to note here that joules is the unit and should be shown in a capital J. Kilo is a measure. It could be megajoules, kilojoules, and so on. So the K can be shown in, or should be shown in small letter, and the J in capital letters. Number 5, questions that require identity of a substance. You find that a substance can be identified, and I want you to underline the word identified, using a name or a correct chemical formula. Take, for example, a question asking students to identify the main product in the survey process. The main product can be identified as, in words, sodium carbonate, or it can be identified using the chemical formula Na2CO3. So the word identify takes 2 points: the name and correct chemical formula. However, number 6, questions that require naming of a substance. For example, a question may be asked, name one byproduct in the survey process. Here, we must strictly answer the question by providing the name and not, I underline the word, not the chemical formula. So the correct answer here would be the name calcium chloride and not the chemical formula CaCl2. Number 7, questions requiring identification of a substance that can exist in dilute or concentrated form. In this case, if a student commits himself or herself, that is, commits himself or herself, the answer must be the correct one. Take, for example, you asked the drying agent, and the correct answer is supposed to be concentrated sulfuric 6 acid. So the commitment of concentrated sulfuric 6 acid must be there. And when the student does not give that, then the student does not score. However, in some cases whereby the identification of the substance, maybe you're told identify liquid X, and the correct answer can be conc sulfuric 6 acid, the student answers. The student identifies the liquid X using the symbols H2SO4 liquid. It's correct. The student does not give any commitment about the concentration and just gives H2SO4. You will earn the mark. Or sulfuric 6 acid, you will earn the mark. Or H2SO4 aqueous, without any commitment, and the correct answer was supposed to be aqueous, then he earns the mark. Remember, we are talking about identify, and we agreed that identify if you give the name or the symbol, and provided there is no required concentration, then the student will earn the mark. Let's look at number 8, drawing the structural formula. The student must show the skeleton of all the bones involved. Indeed, what we are saying, the student must open up all the bones. In my first illustration, I have shown the structural formula of 2-methyl propane with all the bones open. In the second one, the methyl substituent is still in closed form, whereas the rest of the part is open, and that is wrong. So what we're saying is we should not mix the condensed form and the open form in a structural formula. All of them opened. Number 9, students may be required to describe a sequential way of undertaking a particular procedure. For example, describe how one can obtain salts from a mixture of sodium chloride and sand. In this case, the way we write the procedure sequentially and correctly matters a lot. In number 1, we can put add water to the mixture. That's correct step. However, we have to be very careful. Some students may write, or a student may write, dissolve the mixture in water. That is wrong, because the mixture contains sand, and sand, being part of the mixture, will not dissolve. So you cannot dissolve the mixture in water. It should be add water to the mixture. Indeed, you can put it in emphasis that add water to the mixture to dissolve the sodium chloride. Number 2, after adding water, what should we do? The action is stir to dissolve sodium chloride. We are very particular here that we are dissolving sodium chloride since sand will not dissolve. Number 3, filter to obtain sodium chloride as filtrate. A cause and effect kind of an answer. We don't just say filter the mixture. We are so specific about the results of the filtration. When you filter, you obtain sodium chloride as filtrate, and a student can add and sand as the residue. However, since the focus is so much on the sodium chloride, it is important, therefore, to say we need to filter to obtain sodium chloride as our filtrate. And the fourth step is, what do we do with the filtrate? We evaporate the water in the filtrate to obtain sodium chloride salts. So it is important that we note that a candidate is penalized for starting the statement with words like dissolve the mixture. This kind of candidate is a non-starter. His procedure will not start in what is required. So very, very important we look into this. Number 10, questions that involve differentiating or distinguishing two substances. A candidate must account for each of the two substances in the question. For example, there's a quiz question here. Distinguish between ethane and ethene using acidified potassium manganate 7 solution. In this case, the student should be able to put the answer as ethene will decolorize the acidified potassium manganate 7 solution because it is unsaturated organic compound, while as ethane will not decolorize the acidified potassium manganate 7 solution because it is a saturated organic compound. So in this case, we have accounted for each of the two substances and we have shown the difference between the two. Next, we look at questions that require a candidate to compare substances. A candidate must give the differences and the similarities. Number 12, candidates who choose to explain a question using an equation must label the equation fully and include all conditions required, such as heating, the catalysts, the temperature, pressure, among others. For example, explain which substance was reduced when hydrogen gas was passed over heated copper 2 oxide in a combustion tube. If you look at the solution provided by the candidate, he has shown very clearly that the copper oxide in solid form, while hydrogen gas undergoes oxidation to form water. Similarly, a student could write it in words that when hydrogen gas is passed over heated copper 2 oxide, the black copper oxide is reduced to copper metal by hydrogen, while the hydrogen gas is oxidized to hydrogen and some colorless liquid condenses on the cooler part of the tube. However, if you look at this particular question, it was very specific. Explain which substance was reduced when hydrogen was passed over. So we are stating that copper oxide was reduced to copper metal in words or in that kind of a diagram. Let's go back a little bit and we look at question number 13. Questions that require candidates to state and then explain. It is important to look at it this way. Are the two tied? That is, stating and the explanation. So if the two are not tied, a candidate whose statement is correct in the stating, maybe an observation, but has a long explanation, will score half the marks for stating maybe the correct observation, but lose marks for the explanation. But if the statement is wrong, that is, if the statement of the observation is wrong, a candidate will lose all the marks even if he gives a correct explanation, because one cannot explain a wrong statement. For example, in the earlier question that we have just discussed. We may meet a question which says, Roman 1, state the observation made when hydrogen is passed over heated copper 2 oxide. And then Roman 2, explain your observations in Roman 1 above. That is the situation we are having. Correct statement of observation earns 1 mark. Wrong explanation earns 0 marks. It's penalized. However, if the question was state and explain and the two are tied, then the student will not score. Indeed, will lose all the marks as we have explained. Number 14, we look at how questions involving decimals are marked. Decimals are marked correct to at least 2 decimal places. For example, you have an answer coming up to be 0.245759. If the student shows it in that form, it is correct. Or to 4 decimal places, 0.2458, or to the minimum allowed of 0.25. Those are 2 decimal places. However, if the student gives that answer to 1 decimal place, 0.2, that is marked as wrong. So the accuracy, the minimum accuracy allowed here is 2 decimal places. Spelling. Wrong spelling of a term may score, I want to underline the word may score, if the name does not have a different meaning in the dictionary. For example, a student, instead of writing sodium chloride, he writes sodium chloride. So since there is nothing else or no item called sodium in the dictionary, and we give the student a benefit of doubt there that he meant or she meant sodium chloride for that particular answer. Number 16 is on structure and body. Diagrams must be drawn consistently. What do we mean? Normally we say if you are showing covariant bonding, it is good to show the dot and cross kind of diagrams whereby one of the atoms in the bonding takes on the dot and the other atom takes on the cross. So my first diagram as shown on the screen is correct. The first oxygen takes the dots and the second oxygen takes the cross. However, if you look at the second diagram, we have some kind of inconsistency in the sense that the student did show the 2 electrons in the first atom which are not involved in bonding, but omitted to show the inner energy level electrons in the second atom. So that is a form of inconsistency and it is wrong. So let there be some consistency. If you decide to put the innermost electrons, even if they are not involved in bonding, and you want to put them in one atom, they must appear in the other atom that is bonding. Number 17, we look at the comparison of 2 substances in a table. So this one, I advise students to compare similar characteristics or similar items. However, matching is not necessary, but candidates are encouraged to match the points as to avoid wrong answers. And each point scores independently in the table. I've given an example when some student is comparing the luminous and the non-luminous frame. So we would expect if you are comparing the level of hotness, you can see luminous frame is very hot, while the non-luminous frame is very hot. If you are comparing the size and the shape, the luminous frame is large and wavy, while the non-luminous frame is usually small and steady. If you are comparing the aspect of producing soot, then luminous frame produces a lot of soot, while the non-luminous does not produce a lot of soot. Indeed, has no soot, and so on. Number 18. Names of the chemical families must be well written, or rather well spelled out. Take for example, when students are asked about the group 2 elements, the likes of magnesium, they're supposed to say they are in the chemical family alkaline earth metals. Sometimes students make a mistake and they write alkali earth metals, and that is wrong. It should be alkaline earth metals. For group 1 elements, we say they belong to the family of alkali metals, and not alkaline metals. We do not have alkaline metals. It is alkali metals. We give group 2 elements as the alkaline earth metals, and that spelling alkaline should be very well clear. Dear viewers, we've come to the end of this edition of common mistakes or common penalties in KCSE Chemistry exam. I've been your teacher, Steve Gitao, and I do thank you very much for joining me and watching the video.